All right, I think we can start. Hello everyone, my name is Boyan, and today we are going to talk about two important and popular concepts, REST APIs and AI agents. First, I want to start with a very short history of REST APIs, why we have this today. If we go back to 1981, we got the idea of, or the necessity to run software that is located on another computer, not on ours. Before that, we created programs that were running on the same computer, basically, but at some point, we wanted actually to work with programs that are located somewhere else. That's why we got things like remote procedure call, which was actually the concept of calling a piece of code that resides somewhere else, basically in the internet, but it looked as if it resided on your local machine. Later on, different other protocols, frameworks, paradigms kind of reuse this concept, like Corba, then we got XML RPC. They kind of do the same things, just in a different way. Now moving to around year of 2000, the most popular way of building, let's say, backend software that was calling each other was SOAP. SOAP was an entire ecosystem of calling code using XML as a means of transport on HTTP usually. And then around this time, things kind of changed and REST emerged. And this is what we got today, like a lot of protocols, technologies built on top of REST. And the kind of XML kind of got a bit in the corner. Why is this? How many of you remember this application? Yeah, most of you, right? This is a tool called SOAP UI that was very popular at this time because it allowed you to get basically SOAP web service. You could import it directly here, and it would generate a client for you, and you could code this one. So very easy, very useful for debugging or playing around with different web services. And this is how it looked like. This is the XML format of you got a response, like request, and then you got the response in the same way with the different parameters. However, at this time, we as developers we started creating more dynamic JavaScript clients. Basically, our web applications, they started getting more dynamic, more rich, more more playful maybe for the end users. And this was done, of course, with JavaScript. JavaScript was getting better and better at each time. And JavaScript worked with something called JSON. This is kind of the natural way for JavaScript to work with data in this JSON format. XML was not, of course, you could work with XML in the browser, but it doesn't really feel that easy. You had to do some quirks there. That's why we started adopting JSON as a means of transportation, formatting of the data, and that's why REST started getting popularity, because it was very easy to work with your data in the browser. Now, if we take a look, this is a chart that I got from Postman, which is kind of the modern version, I would say, of SOAP UI, a tool that allows you to work with REST services. This is research they have done, and according to them, REST is really one of the most preferred way of using APIs. Of course, we still have SOAP today. We still have different RPC versions. We have things like GraphQL webhooks. These are all different ways of building APIs, but REST is really one of the most popular ones. Now, if we take a look at the simple REST service, like who are our clients? Of course, the most popular ones are the web clients, something that you built in your browser and is calling a web service, getting data, and using that data. Then we got later the mobile applications, right? Everything that you have here, Android or iPhone, does basically the same thing. It calls an API and uses this data. And then we could also build like backend to backend communication. So you could have a REST service calling another REST service, performing something that maybe doesn't even touch the user interface at all. So these are really, I think, most popular way of consuming REST API. Now, if we go to year 2026, coding has changed. In the past couple of years, we have seen a dramatic increase of using AI tools to help us develop. What does this mean? That now we are no longer writing the code ourselves, or at least part of the code, but we are orchestrating. So we are using AI to orchestrate and to perform this for us instead of us doing this. Right? So it could go something like this, ridiculous things, of course, but this is how things are going on in 2026. So now, by having all those AI agents, AI tools, we have really a new kid in the block, a new consumer of our API. And this is the AI agent, basically, that is going to work with our REST APIs, whether we want it or not, as we are going to see throughout this presentation. This is a chart that I found by Human Security, organization that performs analytics, research on the different security aspects. And this is the traffic that they project, and they have analyzed and project regarding AI tools, AI bots. So this is for 2025, but the idea is that it will going to increase in 2026 as well. How much is going to increase? We don't know. It's probably going to reach a top at some point, but for now, we see a constant increase in the traffic generated by AI bots. Now, I like this saying of Marcel Proust, who says that the real voyage discovery consists not in seeking new landscapes, but in having new eyes. So if we reflect on this as humans, what does it mean? That if we look at the same thing, but try to analyze from different perspectives, we might basically see two different things, right? So we could actually argue, and that's why we are different, because we see things from different perspectives, and this is how we discuss things in real life. Agents are not the same as humans, as we know. They have a different way of processing information. This here is just one of the examples. I think it's one of the most popular ones. There are other ways of doing this, but I think they all more or less do it the same way. So when using AI, what do? We start usually with some query expressed in a natural language. So we want something from the AI bot or AI agent to do for us. Then this query goes through a series of, like let's say, pipelines, checks, and it is going to be to become like it might be split to different parts, some subtasks. So the agent will decide using LLM, of course, what to do with this query. It might require calling an API, maybe reformulating this, searching the internet, whatever, like do different things until the agent thinks that, okay, this is a satisfactory response that I can give back. So there is this process of thinking. Now, as we say in 2026, no more loading. Everyone is thinking, right? So this process might continue for some time, depending on what you want to achieve, and depending, of course, on the LLM you use, etc. Now, AI agents are not like us, that when you see something, you might kind of play around with it, try different things. You might get the different ideas. LLMs are taking basically something that is of highest chance to satisfy the criteria, your query, right? And this might not be what you always think it should be. So that's why AI agents, in contrast to people, they want machine readable specification, something that they can rely on and they can use as a base if we don't want them to guess things. And now when we talk about specifications in terms of REST API, of course, the first thing is the documentation. Documentation, this is one of the most boring part for us developers. I admit it for myself. But it is very, very important. And now it's actually more important when we talk about AI. What is documentation for REST APIs? Well, this is an open API standard. This is one of the newest one, is 3+, I think 3.5 maybe, the last one. But it is a JSON or YAML specification of your web services, like what they do, what information they take, what responses they get, and things like this. Actually, if we go back to SOAP, if you remember, this was out of the box because you got the WSDL file, which was actually the entire definition of your web service. Here, of course, unfortunately, we don't have it in REST, so we need to do this ourselves in one or another way. Now, of course, one option is to go and write this yourself. So create a JSON file, say, or a YAML file with this information, following the Open API specification. Another risk could be that you could use a tool to auto-generate this. This is an example in Nest.js, in TypeScript, but I think most of the other frameworks, like in C#, in Java, they have something similar to let you actually generate this Open API specification. The problem is that even that we get this out of the box, at least some portion of it, it is not enough for AI agents. Why? Because AI agents, they parse text. They work with natural language. And most of the time, what we do as developers, if we want to document something, we just repeat the same thing as the method it's called, maybe just with words. If the method is called create order, we say, OK, this method creates an order. Great. But that doesn't bring any more context to the table, right? When we want to make our API strong for AI agents and to decrease the chance of hallucination, we need to put a bit more information about this API there. Like what happens, and we need to display the quirks, like how many times can I call this? Is the information safe to process? What if an error happens, and things like this. So we need to put the information, of course, not to repeat the method, because the agent can definitely read this method, right? But to put some additional information that is not really understood from the method name itself. Actually, this is also very helpful for developers that will consume your API afterwards as well. The same goes for the requests and responses. As I mentioned, in SOAP, we got this out of the box. Unfortunately, with JSON, that's not the case. We need to write some schema, maybe using Zot or something like this. So depending on whether you C# or Java, if it's a type language, you might get many things out of the box. If you use JavaScript or TypeScript, you might need to do something yourself. So this is how things are. But again, we need to be very specific on what is the request, like what fields are there, what is their limitation, etc. Now, my favorite part, the errors. Now, the errors are often something that we neglect every time. Because the positive thing is great, we have the happy path of our REST API, but what we often forget is what happens in case of an error, and what errors do we support, and what shall we do in case of when we get one of those errors. Here we can do a lot of things. We could start, I think the easiest one is just to start with something descriptive of the error. Unfortunately, many validation libraries give you very, very basic input. They say, OK, there is something wrong with the field or with the request, and instead of giving you more information, what exactly was the error here? So this is one of the easiest things we could do. Make sure that we say, for example, what is the problematic field? What options do we support for this field? If it's enumeration, what are the possible options and things like this? Because often AI agents, they try to guess different things, and if they don't guess correctly, they need to know how to repeat the request, maybe with the correct information. If you want, you could go a step further and do something like this. So you could provide a full-blown information about the error. Maybe part of it is directed to your UI, maybe your web client, and then a part of it is directed for your AI agent, if the agent is the client. So you could do something like this as well. So here you could experiment. Basically, the more information you give, the better, and the more choice you give, the better. If you're very, very lazy, you can just use no as a service, which will return a random generated error for all your calls, and then you'll be happy. Your boss won't be happy, but at least you have fun for that. Now, another important thing when we talk about REST is the consistency. How many of you has argued with, let's say, a coworker, what is the most RESTful way of doing things? Come on, most of you, I'm sure. I mean, this is what we do usually with REST, right? And unfortunately, well, there are many ways of doing the same thing, right? And here I'm not going to propose a correct way of doing things. I'll just say be consistent. No matter what you choose, just be consistent across your API. Because AI agents, when they see examples of something, when they see a request response, they can guess other things quickly. And if you're not consistent, of course, their guess will fail, and you will just burn tokens out there. So being consistent is more important than being right here in this case. Now the funny part. Where shall you place your OpenAI specification? This is a tough one. We started having files like Swagger, then we could say OpenAPI, then API docs, then we start talking, let's use the well-known folder, etc., right? This is because we had all these different ways of exposing the API, and there is no right way. I think if we have to choose one, this should be the last one. I think the well-known folder is now that most people agree on that should be the place to store your public information, like OpenAI documentation, for example. But many actually AI agents will probe. They will try all of these URLs and see if anything exists there, and they will use this one. So maybe you are safe to replicate your specification. And now to make this even more interesting, there is a new way of specifying APIs, and this is the agent.json file. And the agent.json file is, well, JSON file that specifies what your website basically exposes as an API. Something similar to OpenAI, but not the same, right? This is, again, a new concept, something that is still being developed. I'm not sure that everyone, not all agents support this one, but still it's something that you might take a look, because the array is still very dynamic. Things are coming and going. Whether this will continue to be used, we'll see after time. But for now, it is something that you can explore. And actually, you could generate agents JSON out from your OpenAPI specification. So of course, you don't have to maintain two files if you're unsure. Now, when we start about agents, we said that what they do is they start with a query. Your query. You have a task. You have a problem that they need to solve for you. And they start the process of doing this to find the right solution. So they need to understand what they need to do, right? Now let's play one game. And this is something that you could do yourself, basically. I did it myself with ChatGPT. And I said, OK, you have a goal. Your goal is to order coffee for me. And I'll be pretending to act as a web server. So I'll be just responding you. So you give me a request, I'll give you a response. And you have to order coffee, right? So that's it. And then ChatGPT said, OK, great, let's start with the coffees 1, 2, 3. And then I said, great, at this page, you get this HTML. So you give a coffee, and you have two links where you could see reviews and orders. Like this is very, very simple. You could imagine like a very uninteresting HTML page with this information. Then ChatGPT would say, great, I need to order, so maybe the order page is the right place to continue. And that's why ChatGPT requests the order page. And I say, great, here you have a form, HTML form, which you can use to order coffee. And then ChatGPT actually submits, makes a form request, post request, with the information about the order. What does this mean? Of course, this is a very, very simple example of HTML. But AI agents, LLMs, are very good at parsing HTML, so they can actually perform tasks as we do. This is what we would actually do. We would open a page. We would navigate different links until we find the correct page that we want to do our job, right? So ChatGPT did exactly the same thing. Of course, with more complex web pages today, this might not happen in this way, because the chance of hallucination gets higher and higher, right? Because on the HTML page, you have newsletter, you have some banners, maybe you have consent about the privacy options, right? Then you'll be asked to subscribe to the newsletter to get a 10% discount. This is how browsing web pages in 2026 looks like. So things of getting something wrong is bigger. Anyone has heard about Hatius? OK, a few people. This is one thing that unfortunately didn't get traction when we talk about REST APIs. it basically states hypermedia as the engine of the application state. The same way as we use anchors, links in the HTML, this is the same idea to use links in the REST API to basically give some context or to do actions that you could do next and next after getting information. How does this look like in real life? Say if we have a REST API that gives information about a coffee, then you could include information about what other actions are there. So great, I have this information about this coffee. What else can I do now? Oh, I can go and get the importer. I can go and make an order, things like this. Exactly the same things as we had with an XML, with an HTML. Now we have this with the REST. So if we compare this, this would be the HTML version of the API. Very, very simple. But then why? I mean, when we saw that AI agents are good at understanding HTML, why bother do this with the REST APIs? Well, the benefit here is that first you reduce the ambiguity a lot, because in the REST API you have only this information, very, very concise, very simple, nothing out of the context that might corrupt the agent or the LLM in the way. And then you give the LLM information and the agent what other steps are there. So now, instead of just having different independent REST API endpoints, you have correlation. You have things that can be done one after another. So you can complete a workflow. And this is very, very, very good and much more efficient than doing web scraping, as we saw before. And now if you decide to use the agents JSON, by the way, you could actually, instead of using ATIUS, you could use the agent JSON and describe the flow there. I told you things are getting fuzzy here, so you need to choose your approach. You could experiment with both and to see if you get some results. But the idea is that you provide the agent a workflow, not just an independent endpoint that does one thing, but a workflow to complete, because this is what usually the agent wants, to complete a workflow. Now, the next important topic in REST API is how to structure our resources, right? Because REST APIs is done around resources, but no one tells you how big those resources should be. It's the same discussion as with microservices. No one tells you how big a service should be considered a microservice, right? And here we have exactly the same thing. How does it look like in real life? Well, the idea is that you might have one big endpoint that returns a lot of information, or you could have smaller endpoints returning just the specific information that you want to do. Well, one of the reasons that we were discussing this before was because the browsers were limited in terms of TCP connections. So the more requests you do, the worse, so they are going to wait. So this is not longer that much a problem. And now we decided to actually split all the endpoints. We have a lot of endpoints out there that deliver only the information that you need on a certain page, on the part of the web page. But why is it important when we talk about agents? Because of this. What you're going to pay in the end of the month, right? All this information about the APIs will go through the LLM, unfortunately, because when the agent calls an API, decides, okay, I need to call an API, the response needs to go through the LLM to be actually processed and to get what is the next action from there. So you imagine that if you are calling an API to return a lot of results, this will cost you a lot. So that's why you need to be very careful about how much information you return from your API if you don't like your clients to hate you afterwards. What can we do here? I mean, there are different ways. I mean, this is one of the probably the dumbest way to do this. I mean, I have done it, probably you have done it as well. You could actually return some base information, and then you could provide a way to kind of expand this information and then return some additional information if the agent gets the necessity. And then some of you might ask, but why not use GraphQL? I mean, isn't GraphQL exactly the same tool to solve this problem? And you'll be right. Actually, GraphQL is indeed a tool to solve this problem. Whether you want to use it or not, of course, it depends on your situation, whether you already have it, whether you want to introduce it and maintain it. So just you need to be aware of this. We move on to the next fancy word, idempotency, right? This is something I remember. This is one of the terms that when I was young, and there was one of the older colleagues, they come to the office and start arguing with you and use this: is your code idempotent? And then you feel this, you are scared because you're not sure what he means. You say yes, maybe, but you get the respect from this person, right? What is the idea here? The idea is that some operations are not to be repeated. And this is very difficult to achieve when we have networking, because in the networking, you might get an error in the many situations, maybe in the request, maybe in the response. So if you retry an operation, it might become a problem if the server, like the REST API server, does not acknowledge or does not allow repeatable operations. For example, if you do banking operations, right, you want to make sure that if you do credit or deposit, it will be executed only or at most once, these kind of things. Why is this a problem with AI agents? AI agents are very unpredictable. At some point, they might decide that calling your API multiple times is a great idea, and you can't do nothing about this, right? So you need to make sure that your API supports some crazy consumers like LLMs, and you need to react properly when they call your API multiple times and return proper error, of course, indicate what should happen there. But there is another consequence of the agent calling you multiple times. And this is the rate limiting. The rate limiting part. How many of you are using rate limiting or have implemented rate limiting? Great, yeah, some of you. Why do we want rate limiting? I mean, usually we want to prevent some overconsumption of some resource. Maybe we have a very slow internal API that want to protect of being called multiple times. Maybe our database is very unstable, so we are not sure if, let's say, 1 million people contact our API right at the same time. So these kind of things, we want to kind of protect a resource. Then we want, of course, to make sure that the cost is under control. What happens like if your API is called thousands of times and then your Elasticsearch logs suddenly explode? You're going to pay for this, right? And then probably want to get some money out of this API, like many other APIs do. You offer some free calls, maybe some free requests per month, and then the rest is something that you want the client to pay for this. Now, this here is one of the very simplest example, just for the others that are they haven't used the rate limiting. Like, what do you usually do? There are different algorithms, but usually you have a fixed quota. Say in this example, you have 3 requests allowed per minute. So you want to make sure that like 4th request will be rejected and so on, like within the same minute. And this is the fixed windows algorithm where each minute is really one window. There are different algorithms that work in a similar way. However, this is not going to work exactly like this for LLMs. And we're going to see why. When we use with rate limiting, we usually choose a static quota. We say, OK, X requests per month, for example, or something like this, or maybe per minute. We could actually have different limiting strategies for different APIs. Let's say if you have a billing API, you might be more conscious about. If you have some other APIs, you might be more flexible, say. Like, what we need to do first, of course, is to make sure if we implement this ourselves, if we use something like Cloudflare or Azure, they handle this for you. But usually, you need, of course, to return the correct status code. Most of the time, this should be 4 to 9, too many requests. Some older services would use 503, but now most of the people suggest that 4 to 9 is the correct one. You might want to include, like, when is the next possible time to retry this request? Why is this important? Well, if you don't do this, you rely on the client to retry. And the client might decide to retry basically every second or every like half a second or something like this. You don't have the control over this. And of course, all the requests that they make redundantly will result in, let's say, more logs for you, more network that you need to carry over. Of course, again, if you use something like Cloudflare, you shouldn't care about this. If you're a client, this is how a smart client could do this. Like if you make a request, for example, and this is then you choose, you see, okay, if I'm being rate limited, then great, I'll try to see if there is information when I can retry next. Otherwise, I'll do something like exponential backoff. This is usually the safest strategy, but you can't know what the client will do. This is out of your control. Now, this year, this chart shows the traffic by different AI bots and shows how sporadic they are. You don't have, again, control over how many requests they will make and how quickly they'll make those requests. And you have to choose. If you want to be more flexible and allow AI bots to use your API, even if they basically exceed the rate limiting, you need to do something different because the current algorithms are not enough for this. This is Elon Musk that actually extended their limits a couple of times of their APIs because of the increased traffic of the AI agents using their APIs. So you could see that even they are not safe when APIs are being called by AI agents. So we need to do something different. We need, instead of using static quotas, we need to be a bit smarter here. We need to first analyze the traffic. How are we going to analyze the traffic? Of course, we use AI tools, just other AI tools for this one. And then, if we see that this is traffic coming from LLMs, basically, we might decide to increase or give a special maybe quotas for this particular client, right? By doing this, we will allow, of course, the client to complete the goal, and the end user, you, that started the query, will be happy, of course. So instead of using static quota, we need something called adaptive rate limiting. And there are many tools that are doing this, also Cloudflare, Azure, other like similar services are experimenting with this. It's still something new, of course, but it's something that you need to consider if you want to expose your APIs at scale. Now, every SaaS company is now an API. So I guess most of you work in some products, SaaS companies, or are working for clients doing this. Now, your company, whether you like it or not, is an API. How does this work, you might ask? Well, if you have an AI agent, if your company has an API, they will use it. Great. They will use this one because REST APIs, they're public. I mean, your web page uses them, your mobile application uses them. Of course, the agents can use them as well. How well documented they are depends on you. How efficient those APIs are depends on you, but they will be used. If you don't have an API, you could expose something like Model Context Protocol. How many of you have experimented with this? With MCP? Great, yes. We had a couple of talks today, which are very great, and something that is still, again, very new to the AI agents and the communication with APIs. But the idea here is that it's a standard way of exposing tools to your agents. And then, of course, if you have a REST API, then you could wrap it and then expose it as an MCP. Many actual agents will do this. They will consume the OpenAI, and they will internally create an MCP server for them as one-to-one. The problem here is that if you have one-to-one mapping between endpoint and an MCP tool, you don't gain much here because agents are interested in the workflow. They want to complete the entire task. So instead of making the agent call 10 APIs, just create one tool that internally calls those APIs and orchestrates this. This is much more efficient for you. Now, option C is something called WebMCP. This is a new standard coming to the browsers. It's driven mainly by Google and Microsoft, but other companies are joining there. The idea is that your page can expose MCP tools the way you browse them. For example, if you open Chrome, actually Chrome has experimental feature that you can enable and play around with this. You can expose your tools the way you open your page, and your AI agent, whether it's connected to the browser or it's, let's say, a browser extension, like Claude, for example, right, can use and consume those tools dynamically. How does this look like? This is a very, very simple example. Like, let's say I want to have a page where I want to clients to order coffee. So I can say, OK, great, I have a tool called order coffee, and then I can describe, of course, the input, the output with some schema. And then I will have the code that actually does this. Internally, I might probably call my REST API anyway, right? But I expose this as a tool, as a workflow to the AI agent. And this here, I did a short example with Cloud Desktop, basically, which is connected to Chrome. Again, this is experimental. And I ask Cloud, hey, I want to order the best, basically, Ethiopian coffee right away for you. So just find me the best coffee first. So now Cloud will just search the internet, do its magic there, right? And it will give me some results. And at some point say, OK, great, here's the result. I can offer this is the best Ethiopian coffee so far. And then I say, great, if this is the best coffee, please order some amount for me. And this on the left, it's a page that I have created locally. It exposes this tool that I showed you, basically. It exposes this tool. So now Claude will analyze this and say, great, I'll see what I can do to order a coffee for you. And then I say, great, I can do this. I can actually order you this coffee. This is the same amount. Just confirm. I say, yes, do this. And now Claude is actually calling my tool that I exposed. So you can see on the left, now it will do some magic. Yes, now it's ordered coffee. I say, great, now the coffee is ordered. And Claude will confirm this, order is placed successfully. So now every page can become a tool, right? MCP tool, which will, of course, allow the AI agents to use it dynamically. If you want to play around with this, this is one of the best resources so far because it's experimental. They have, of course, all the packages that you need to work with this. You can experiment with it locally. It's actually pretty fun to work with this one. And now, I mean, if you don't care about anything, of course, as we saw, AI agents will just do web scraping. I mean, nothing we can do about it. They're pretty good at this. I mean, it's not the most efficient way, but agents are good at this. And then you might say, I mean, why bother? I mean, if agents are good at scraping, why shall we bother like taking a look at our API, spending time on improving documentation and things like this? Well, the real reason here is that efficiency. Like Cambridge Dictionary chooses one word every year as the most influential word of that year. In year 2023, this is the word they chose, hallucinate, because this is when we start experimenting with ChatGPT and everyone is talking about hallucination. The problem is that LLMs are not like us. They choose the most probable outcome for our actions, but this might not be the most efficient or the best one that we want to do in this very moment. The benefit of you taking care of your API is that you control it. You know what you expose. You have the full control of this, and you reduce the chance of the AI agents to make a mistake there. Because, I mean, let's be honest. What happens now is that agents, they develop preferences, like we do. I mean, how many of you will wait for a page if the page doesn't load in, let's say, 5 seconds or something like 5, 6 seconds, right? We'll close it. Well, very few people. Right? You are very patient. But if you are like most of the people, you just close it and just open another page that probably has the same information from the search results, say, right? The agents will do the same. They will develop preferences. So they will choose the API that is most efficient, that returns clear information that the agent can actually achieve the goal, the given goal. And then we, as humans, will become approvers. I mean, if you want the agent to buy your tickets, you don't care where they'll buy them from, probably most of the time. You say, OK, just give me a couple of options. You say, great, I like this one, the price and the date. it's okay. I like it. I mean, why bother? And then the companies, like the many companies that do the same thing, of course, one will be chosen. One will be chosen as the best one, the one that has really the most efficient API. So I like this quote by Emerson, who says that nowadays, like the SaaS is like a building with two doors. One is the agent, and the other is basically for humans, for us as the users. But they're in the same building. So of course, if one of those doors, one of these parts of the building is has problems, the other one will be affected as well. So we need to think about this. And I mean, we've been talking about developer experience many times, and often we neglect it because we want to spend our time on features, fixing bugs and things like this. We never really want to say this because, I mean, if our API is only aimed to be consumed by our own web client or mobile application, why should we bother make it nicer for other developers? It's not meant to be consumed by other developers. But now, it will be consumed by other AI agents. So, what shall we do? If we're building an SaaS company today, an API, first, I would make the API really an important metric. I mean, many companies, they use OKRs, KPIs, different ways of tracking the progress of your product. I would really include API quality as part of this product. Then, of course, you need to audit like the API, like documentation, performance, security as well, right? To make sure that it actually satisfies all the requirements, all the constraints, all the best practices out there. Now, actually, many hackers, newer hackers, they're actually not using anything obtrusive. They're just using natural language to bypass your information, because many companies are deploying AI agents, maybe for different service agents, support, and things like this. And many people, bad people, are actually using this as a way, as a door to your company, just using the natural language. So something that you need to be careful with. And of course, have a look with the competition, because many companies nowadays, many startups, what they do is they build the API first version of your own company. So they will have a very good API. They don't care about the user experience, but they will have a very good API, very fast, very efficient, that will do the same as you. Maybe buy flight tickets or book rooms in hotels and things like this. So be careful about this competition, because they will be the preferred API for AI agents in the future. And I think that the future of APIs now, it's not just machine readable. I think it's very important to be also machine understandable. Thank you so much for coming here. If you have any questions, I'll be happy to hear them.